Today we are going to see the force exerted by the jet on the plate. But for that we must know the force exerted by the jet is equal to the rate of change of momentum. The rate of change of momentum is equal to initial momentum minus final momentum. So initial momentum is nothing but mass into initial velocity minus final momentum is equal to mass into final velocity divided by time. So for finding out mass, the force exerted by the jet on the plate or hinge plate is equal to mass upon time into bracket initial velocity minus final velocity. But mass per unit time is nothing but mass per second, and which is equal to rho, that is density of the fluid, into q is discharge or flow rate. We will find out q by is equal to area into velocity, where a is the area of the jet. So area is equal to pi by 4 into d square, where d is the diameter of the jet. So force exerted by the jet on the plate is equal to rho av into initial velocity vi minus final velocity va. In case of hinge plate, now in this as shown in this figure, this OP is the total length of the hinge plate, where point O is the hinge point. This total length we are calculating it by using h, which is nothing but the total length of the hinge plate. Now this is the nozzle from which water is coming out. So water or the water jet is coming out through the nozzle with the initial velocity v and the diameter is small d. So when this jet is striking the hinge plate at point A, the distance of OA is nothing but x. So after striking this hinge plate is rotated about an angle theta. We call it as swing angle, and we are going to find out this angle also. So after striking the jet, this hinge plate is rotating at an angle theta, which will because of that this point A is moving to point A dash, and this total OP is at OP dash. Okay, so this OP is nothing but total length of the hinge plate, that is L, or this is H. Total length is equal to H, and where the jet strikes at point A, which will after striking will move to the position A dash. But this distance OA is equal to x will remain same, that is OA dash is also x. To find out this, the normal force exerted by this jet on the hinge plate, this Fn normal force striking at point B in this jet direction. Okay, so this is normal force, and we are going to find out this normal force by using formula. The force exerted by the jet on the plate is equal to the rate of change of momentum, which is equal to mass flow rate into initial velocity minus final velocity. Now in this case, final velocity after striking becomes 0. Now initial velocity is equal to nothing but this Vn is nothing but our v cos of theta. Now to find out the normal force, Fn is equal to m dot vi minus va. This is the formula for finding out the normal force, that is equal to m dot vi minus va. M dot is nothing but mass flow rate into initial velocity minus final velocity, that is equal to mass flow rate is equal to rho into q, where rho is the density of the fluid. Here we are using water as a fluid, so we are taking the density of water. Rho into q is discharge, that is area into velocity, or flow rate is equal to area into velocity, where area of this jet. So to find out area of the jet, pi by 4 d square. So d is the diameter of the jet. So rho a v is nothing but our mass flow rate. So rho a v into initial velocity is vi minus final velocity is 0. Initial velocity is nothing but our v cos of theta. So putting the value of this initial velocity rho a v into v cos of theta minus vap is 0, final velocity is 0 after striking. So the formula or the force exerted by the Z on hinge plate, normal force is equal to, we get rho AB square cos of theta. Now to find out this swing angle theta, we have to take the moments about hinge point O. The summation of forces, all the forces is equal to 0. By taking this moment, there are two forces acting on this plate, the weight of that plate and the force exerted by the jet, normal force. Now in this case, by taking moment about this point O, that is this W, so this W sin theta is the force, so W sin theta into OA dash. So OA is equal to OA dash is equal to this x remains same, this length becomes same. So W sin theta into OA or OA dash is equal to x. So W sin theta into x, this is the force and this is the distance about hinge point O. Now second force is Fn, normal force. To find out this distance of this Fn from this hinge point O, this distance is OB. To find out this distance, we are using the triangle, from triangle OAB, that is this triangle OAB. From this triangle, that is cos of theta is equal to nothing but OA divided by OB. But our OA is equal to x, so cos of theta is equal to OA divided by OB. So cos theta is equal to x divided by OB. To find out this distance, OB is equal to nothing but x divided by this cos of theta. Now these, putting these values by taking moments about O, W sin of theta into this OA dash x minus this Fn, minus because in anti-clockwise direction, so Fn into this OB. So OB is nothing but our OA divided by cos of theta. So W sin theta into x minus this Fn into OB is nothing but x cos theta. So that is equal to W sin theta into x minus Fn is nothing but rho AB square cos theta, as we have already find this. So rho AB square cos theta into x upon cos theta. So cos theta gets cancelled out. Now remaining things, W sin theta into x, that is equal to rho AB square x. So x gets cancelled out. So W sin theta is equal to rho AB square. Now W sin theta is equal to, from this we get sin theta is equal to rho AB square divided by W. So theta is equal to sin inverse of rho AB square divided by W. This is the formula which is going to help us to find out the swing angle theta when the hinge plate rotate at an angle theta.